The overall conviction among most specialists is that the hypothesis of how things came to be remains the fundamental explanation for the early seasons of the universe. This theory includes the development of stars, planets, and life on those planets, including ourselves. Oddly enough, it is named the Big Bang. The Big Bang hypothesis offers an illuminating examination of what could have occurred. At first, the universe was dense, contained in a short space smaller than a pinhead, with particles densely packed. From this moment, a giant explosion of matter and energy occurred, an event known as the Big Bang. This event, happening billions of years ago, set the stage for the unfolding of cosmic history. However, advancements in scientific knowledge have uncovered growing inconsistencies with the assumptions of this theory. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever, scientists hypothesized that its observations would confirm the Big Bang theory. Unfortunately, after just a year in space, the telescope confounded scientists with its ability to peer so deeply into the universe's past. The James Webb Telescope's remarkable capabilities have revealed countless galaxies dating back to an age so ancient that they challenge our understanding of the universe's beginnings. This discovery has sparked intense investigations into what may have existed before the Big Bang. One critical moment in this mission occurred when cosmologist Rohan Naidu, working with data from the telescope, unexpectedly discovered a galaxy from only a short time after the Big Bang. This finding made it the most distant galaxy ever observed. Naidu's discovery sent shockwaves through the scientific community, highlighting the astonishing abilities of the James Webb Telescope. Its primary mission, to transform our understanding of the universe, has only just begun, promising to uncover surprising insights into the earliest stages of the universe's existence. This period, hardly examined before, holds the key to understanding the formation of the first stars and structures. The telescope's findings have contradicted initial hypotheses, revealing galaxies with properties surpassing previous expectations. This stunning surge of early galaxies has triggered a storm of scientific inquiry, challenging researchers to reconcile these findings with existing theories. As scientists grapple with these revelations, they face fundamental questions about the very nature of the universe and the forces that shaped its development. Beyond its groundbreaking discoveries, the James Webb Telescope itself is an incredible feat of engineering. Positioned 1.5 million kilometers away from Earth, it is shielded from natural interference and cooled to near absolute zero by its tennis court-sized sunshield. The telescope features a massive segmented mirror and incredibly sensitive instruments designed to uncover details of the early universe previously hidden. This era, known as the Cosmic Dawn, occurred a few hundred million years after the Big Bang, marking the formation of the first stars and galaxies. The process by which this unfolded remains a topic of intense research, with theories ranging from the effects of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's view of galaxies from the cosmic dawn presents a unique opportunity for astronomers to test their interpretations of these complex dynamics. By studying these ancient systems, scientists can either validate their current models or uncover gaps in understanding that could lead to groundbreaking discoveries. Initially, the telescope was expected to observe only a few faint and small galaxies in its pilot studies. However, reality has far exceeded these expectations. The telescope's early images of the distant universe revealed an abundance of galaxies with ages, sizes, and brightness levels that defied all predictions. This extraordinary surge of early galaxies has triggered a race among space scientists to set new records for the earliest known galaxies, with new discoveries emerging regularly and leaving the scientific community in awe. Following the James Webb Telescope's groundbreaking findings, experts and observers have rushed to re-evaluate. The presence of these shockingly progressed early worlds has led some to hypothesize that errors in the telescope's interpretation of immense observations could be responsible for these unexpected discoveries. That said, the consensus remains that these findings represent a paradigm shift in how we understand the early universe, providing exciting insights into the potential for astronomical advancement. The new discoveries from the James Webb Space Telescope regarding galaxies have raised fundamental questions about the nature of the universe and tested the assumptions of standard cosmological models. While certain scientists are exploring whether these observations can be reconciled with existing theories, Others suggest that they may be the first indications that the universe is far more complex and enigmatic than previously imagined. At stake is our basic understanding of how the universe we know emerged from primordial chaos. The early findings of the JWST could reshape our fundamental ideas of cosmic history, revealing insights not only about distant galaxies and ancient structures but also about the very nature of our own Milky Way. As Mark McCaffrian, Senior Advisor for Science and Exploration at the European Space Agency, puts it, "You build these machines not to confirm theory, but to break it. You simply have no idea how it will break." The origins of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, even before the Hubble Space Telescope was launched. At the time, Garth Illingworth, then head of STSCI, was tasked with envisioning what could come after Hubble. Despite initial skepticism, Illingworth and a small team began laying the groundwork for what would eventually become the James Webb Space Telescope. Unlike Hubble, which primarily captures visible light, the JWST was designed to observe in the infrared spectrum, allowing it to peer much deeper into the universe. This capability is crucial for studying distant galaxies whose light has been stretched into the infrared due to the expansion of the universe, making them invisible to telescopes like Hubble. With its massive, cold, star-like mirror, the JWST became the premier tool for unlocking the mysteries of cosmic dawn. The need for the JWST was underscored in 1995, when the Hubble Deep Field observation revealed thousands of galaxies in what was believed to be an empty patch of sky. This discovery highlighted the richness of the early universe and emphasized the need for a telescope capable of probing much further into cosmic history. After decades of development and a cost of approximately $10 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most critical year of scientific observations. Early initiatives, such as the Early Release Science Program and the General Observer Program, were specifically designed to search for early galaxies. While initial expectations were modest, the results far exceeded them. JWST observations have challenged existing models of the early universe, revealing galaxies that defy conventional cosmological assumptions. These surprising discoveries underscore the importance of pushing the boundaries of scientific inquiry and highlight the remarkable capabilities of cutting-edge technologies like the James Webb Space Telescope. As researchers continue to analyze JWST data, they may uncover further insights that challenge and expand our understanding of the universe. When the first data began arriving from the JWST, cosmologists eagerly awaited the results. Many had been preparing their data analysis pipelines for this moment for years. Rather than following the traditional peer review process, which typically takes months, researchers chose to share their discoveries on preprint servers like AR14, a platform for research papers not yet reviewed by experts. This approach allowed for a new kind of peer review to occur through social media platforms like Twitter, where the scientific community could quickly discuss findings. Rohan Naidu described this process as science by press release, with the resulting storm of discussion being both extraordinary and striking. However, there were concerns about the potential drawbacks of this rapid dissemination of results. Klaus Pontoppidan, a JWST project scientist at STSCI, cautioned that while the quick sharing of results facilitates rapid dissemination and discussion, it also risks overwhelming the process. The general consensus among most researchers is that the Big Bang theory remains the primary explanation for the early stages of the universe. This theory encompasses the formation of stars, planets, and life on those planets, including ourselves. Despite its somewhat peculiar name, the Big Bang offers a crucial explanation for the origins of the universe. The universe was once densely packed into a space smaller than a pinhead, filled with tightly compressed particles. From this moment, a massive explosion of matter and energy occurred, known as the Big Bang. This event, which took place billions of years ago, set the stage for the unfolding of cosmic history. However, changes in scientific data have led to growing disagreements with the assumptions underlying this theory. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever built, experts predicted that its observations would support the theory of the universe's origin. Surprisingly, after just 1 year in space, the telescope astonished scientists with its ability to peer deeply into the universe's past. The JWST's remarkable capabilities have revealed galaxies dating back to such ancient times that they challenge our understanding of the universe's beginnings. This discovery has sparked intense investigation into what may have existed before the Big Bang.